You've spent weeks finalizing the script, locking in character Bibles, and perfecting the storyboard, but the raw footage tells a different story. A tight narrative and consistent character design are absolute prerequisites for any successful short drama. You need them to even get in the game. Yet, that entire foundation crumbles the moment the generation layer fails to deliver. All the dramatic tension built on the page disappears if the image falls apart on screen. When a character's hand phases through a coffee cup or their face jitters during an emotional monologue, the viewer's immersion is immediately broken. The human eye is incredibly sensitive to these physical rendering failures. If the final output looks like a glitching slot machine, your audience will scroll past. Mastering the story logic simply doesn't matter if you can't reliably control the render. Relying on a single text-to-video model across a full production no longer meets professional standards. The technical gap between specialized models has widened to the point where generalist tools create too many points of failure. Production in 2026 requires a modular architecture. You have to select specific models based on the exact constraints of each individual shot. Professional output relies on three distinct pillars: precise model mapping, deterministic prompt architecture, and agentic automation to handle logistics. The objective is to stop hoping for a lucky generation. We are engineering a pipeline that turns AI from a random image generator into a highly predictable rendering engine. Scaling a high-quality short drama operation requires replacing guesswork with rigorous, repeatable systems. If your primary constraint is raw visual fidelity, achieving the absolute highest resolution and lighting accuracy, global tools like Google Veo 3.1 and Runway Gen 4.5 set the baseline. However, short dramas demand specific narrative mechanics. For structural reliability in character movement and pacing, dedicated Chinese models have specialized to meet those exact production needs. This diagram plots the major AI video models against four core production requirements: physical realism, dialogue and lip sync, dramatic tension, and visual fidelity. Notice where Kling AI 3.0 lands. It completely dominates the physical realism quadrant. When your scene involves complex physical interactions, characters picking up objects, navigating tight spaces, or conveying grounded realism, Kling is the optimal tool to deploy. Look at how it handles fluid human mechanics. Even in a high-friction scenario, like a grapple in the rain, the physics remain entirely intact. Now look at Cdance 2.0. Its architecture prioritizes very different performance data. For any sequence driven heavily by dialogue, Cdance is essentially mandatory. It maintains natural facial movements and precise lip synchronization that other models struggle to track. Then we have Hilo and Minimax, occupying the space for dramatic tension. These models excel at pacing. When the script calls for an emotional climax or a rapid, high-tension sequence, Halo generates that specific kinetic energy highly effectively. You create an operational bottleneck when you ask a model to perform outside its specialty. Forcing a dialogue-optimized tool to render a complex physical fight scene will almost certainly result in a broken render. Every routing decision in your pipeline must be dictated by the functional requirement of the scene itself, completely ignoring which brand happens to be trending. Even if you perfectly match the tool to the scene, that model is entirely dependent on the instructions it receives. Conversational, vague inputs, like a man looking sad in a room, leave too much to interpretation. In a specialized environment, ambiguity leads directly to rendering errors. To extract professional results, we treat the prompt as a rigid, multivariable equation. We call this deterministic prompt architecture. The first variable is the scene description. This isolates the physical reality of the shot, establishing exactly what the environment is and what primary action is occurring. Next is camera movement. You must dictate the spatial mechanics and lens behavior explicitly. The third block is emotion and acting. This injects the precise performance parameters for the AI to interpret. Fourth is lighting and atmosphere. This controls the visual tone, depth, and overall aesthetic. The final variable is the character reference. This acts as the continuity anchor for the entire production. If you fail to lock this variable down tightly across every single shot, your protagonist will look like 5 different people, destroying the narrative entirely. By strictly adhering to this syntax, you can isolate variables. You can run the exact same prompt through multiple tools simultaneously and accurately evaluate which model handles the constraints best. When you control every input variable, the output reflects that precision. Subtle microexpressions hold up even under intense, highly cinematic lighting. Consistent, reliable generation is the direct result of a human operator enforcing this rigid syntax structure on the machine. Enforcing that strict syntax creates a new operational challenge. Writing highly detailed 5-variable prompts for hundreds of individual shots requires immense manual labor. This is where you deploy AI agents to automate the heavy translation layer. The automated pipeline begins with a standardized, structured storyboard document. You program a dedicated AI agent to ingest the raw text and visual directions straight from that storyboard. The agent's primary function is translation. It automatically extracts the relevant data and reformats it directly into those 5 strict syntax blocks. But the agent also handles intelligent routing. If the agent scans the storyboard and detects a dialog tag, it automatically routes that specific, fully formatted prompt via API straight to Cadence 2.0. By automating the translation and routing layer, a pipeline that used to require days of manual data entry executes in seconds. You spend less time wrestling with prompt formatting and more time actually directing the dynamics of the shot. AI agents shift prompt engineering from a manual task into a scalable production engine. High-quality AI short dramas are not the result of fortunate prompting. They are the product of rigorous engineering systems. The visual pipeline requires 3 distinct steps. You map models to constraints, enforce the multivariable syntax, and deploy agents to automate routing. Reverting to a generalist workflow guarantees a subpar product. Tools are too specialized to ignore their specific strengths. However, locking down the visual pipeline only solves half the equation. In Part 3, we will deconstruct the audio stack. We'll examine AI voice generation, explore music synthesis, and post-production workflows for precise lip syncing. Because in order to maintain true professional immersion for your audience, your visuals must be supported by an equally rigorous audio workflow.